So, good morning or good afternoon. The bell ringer today. Let's think about this for a second. Why are different colors used in maps? You know what I'm talking about. So, Arizona and Colorado are right next to each other, but do they need to be colored differently to easily distinguish them on the map since they neighbor one another? When you think about that, and all the states in the United States, how many different colors do you think are used on the map? Many of you have seen an atlas, and lots of different countries and states that have borders to each other, they're sharing different colors. So why do you think that is? And why are different colors used on maps? And how many total colors do you think they have to use? So ponder that for a little while. Meantime, let's talk about some good things. Tell us about something great that recently happened to you, or tell us about something great that recently happened to a loved one. I'm not sure about you, but got some feedback on a few things going on around the house, and I've got a lot of people telling me that they really like what we're doing around there, and it's got me encouraged to continue doing what I'm doing. So let me know what's going on good with you. Send me a message via the Google Classroom, and I'd love to share it in a good things in a later broadcast. So, learning objective today, I can create graphs conforming to specific coloring properties, and I can create graphs associated with maps. All right, and the I will statement, I will identify efficient ways to graph using real world situations. Okay. Unit 7 on networks and graphs, that's the unit we're in. We're in SAS 9, that's student activity sheet 9, map color. So, the map coloring problem, let's discuss it. You are the publisher of a new edition of the World Atlas. As you prepare the different maps for printing to put in this atlas, you need to make sure that the countries adjacent to each other, ones that share common borders, are given different colors. So, decide how to color each of the 5 countries in the graph or map in map 1 and map 2 so that no 2 adjacent regions or countries are colored the same. Treat the outside region as a single country. Perhaps it represents an ocean-colored blue. Assume that every country is composed of a single contiguous region. For example, you treat Alaska and Hawaii as separate regions when constructing a map of the world. Okay, our answers are A, map 1, each region a different color, and map 2, each region a different color. How about B? Map 1, regions 2 and 4 can be the same color, while all the other regions are a different color. In map 2, regions 1 and 3 can be the same color, while their other regions are all different colors. That's possible too. There's also C, map 1, regions 2 and 4 can be the same color, while the other regions are all different colors. In map 2, regions 1 and 3 can be the same color, and regions 2 and 4 can be the same color, and region 5 has to be a different color of all the colors. I mean, if you look carefully, 2 and 4 are really not touching. All right. How many colors do you use to color each map? So how many colors do we use to do map 1? And how many colors do we use to do map 2? Let's see. 1 and 3 are adjacent, so they have to be different. 1 and 5 and 3 and 5 are all adjacent, so there's 3 colors. But 2 and 4 are not adjacent, so we would only have to use 4 colors on map 1. How about map 2? As I said in the last one, 1 and 3 could be the same color because they're not adjacent. They don't share a border. And likewise, 2 and 4 are also could be the same color because they don't share a border. And 5 would have to be different. So that would be 3. The color you use for 1 and 3 regions, the color that you use for 2 and 4 regions, and the color you use for region 5. All right, let's continue. All right, you want to color each map using the least number of colors, still keeping adjacent separate colors. How many colors are needed for each map? We just answered that question, but let's go ahead and look at it. Map 1 needs 4, map 2 needs 4. We already said no. Map 1 needs 3, and map 2 needs 4. No, I don't think that works because map 1 needs 1 extra color, doesn't it? C, map 1 needs 3 colors and map 2 needs 3 colors. Not quite. And D, map 1 needs 4 colors and map 2 needs 3 colors. I think D is your best possible answer. We discussed that. You can see that's the most likely answer. All right. Which of the following maps requires at least the use of 3 colors? Okay, let's look at map 1. We've looked at it. We know it needs 4 colors. Map 2, we've looked at it. We know it needs at least 3 colors. And map 3, it looks like it needs 1, 2, 3 colors total. So all of them require at least the use of 3 colors. Now, which of the following maps with 4 or more regions could be colored with only 2 colors? Now let's look at map 4. It looks like every region is adjacent to every other region except for the teardrop and the triangle. So you would need 1, 2, 3, 4 if you include all the region around the outside of the map. Okay, so that wouldn't work. How about this one? Map 3, this region is adjacent to that. This region is adjacent to that. This one's adjacent to all 3. This one's adjacent to all 3. They're all adjacent to all the other colors or all the other regions except for the middle one is not adjacent to the one outside. How many regions do we have? Well, if we count the outside, there's 1, 2, 3, 4, 5 regions. Interesting. But we're going to need at least how many colors? 1. The outside and that inside is 1 color. 2, 3, 4. Yep. Okay. How about map 2? It looks like the center little sliver is not adjacent to this outside circle, and it's obviously not adjacent to this outside circle. But this section right here and this section right here, they're not adjacent to each other. They're not the same. And they're not adjacent to this outside color. Those 3 regions can all be the same color. This region and that region can be the same color, so we'd only need 2 for map 2. So that follows it. How about this one? Same thing here. The center circle is not adjacent to this outer circle, and it's not adjacent to the outside. And that middle circle is adjacent to the center and the outside circle, but it's not adjacent to this outside here. So the center circle and this outside circle could be the same color, and this middle circle and the outside region can all be the same color. So map 1 and map 2 fall into that category where they need 2 colors only, okay, for the regions to be colored. What is the largest number of colors required to color any map that keeps adjacent regions separate? That's kind of a tough one. But if you think about it, there's a way to determine it. And it has to do with graph theory. You may not think that way, but in a minute, you're going to see exactly how it works, okay? So is it 4, is it 5, is it 6, or is it 7? I don't think it's as many as you think it is. So let's take a look. All right, I'm going to launch you on this, and then tomorrow we'll go a little bit further in depth into map coloring and using graphs to describe those map coloring. In the few years I've been teaching, I found that teaching children to count is fine, but teaching them what counts is best. It's good wisdom to go by, and I think you should understand that understanding what is more important is not just knowing how to count, but to understand what really counts in your life. So there's an assignment in the Google Classroom, and I expect you to get busy on it. Have a ball, y'all, and be blessed. Be a blessing.